and powerful this attractor is. There are 300 billion stars in the Milky Way, most of which are a lot smaller than the Sun. Astronomers believe that whatever is dragging us toward it has the mass of 1,000,000,000,000 suns. And it's only 220 million light years away. Now, that's still pretty far, but you know, I'd be more comfortable if it were a little farther. We know that it's there because we know that we're moving, and we should be moving. The universe is expanding. That means that all of the galaxies in the universe should be getting farther apart. This apparent movement of galaxies in relation to each other, as the space between them grows, is called the Hubble flow. But since the mid-1970s, we've known that we've been moving at a specific rate and in a definite direction in addition to this apparent movement. This deviation from the Hubble flow is referred to as an object's peculiar velocity. And in the 1970s, we figured out our peculiar velocity by tracking the movement of the Sun through the Milky Way with reference to the universe's general background radiation. And it turns out, we're moving more than 600 kilometers per second, right toward the constellation Centaurus. To give you some sense of how fast that is, if the Earth were orbiting the Sun at 600 kilometers per second, a year would only be 18 days long. Now, we're not actually closing the distance between us and whatever this thing is, because it's caught up in the Hubble flow too, so it's moving away from us, but much more slowly than it should be. So, obviously, astronomers have been wanting to figure out what's going on. At first, they thought it had to do with the fact that the Milky Way is on the outskirts of a broader neighborhood of galaxies called the Virgo supercluster. So maybe we're being drawn in by its gravitation, but even though the Virgo supercluster has a couple hundred galaxies in it, it's not nearly massive enough to draw us in that fast, which meant there had to be something even bigger behind it. By the early 1980s, astronomers realized that it wasn't just us that was moving towards Centaurus, it was everything within hundreds of millions of light years of us. But we can't see what we're heading into. Why not? Well, we can't see about 20% of the universe around us because our own galaxy is blocking our view. And it just so happens that this enormous thing is in that 20%, behind the plane of our galaxy. This region of space, called the zone of avoidance, is so chock full of nearby stars and dust that the only way that we can observe anything behind it is by searching for X-rays and infrared light, which can sometimes penetrate it. But that picture it gives us is not very clear. By the early 1990s, those X-ray surveys had revealed to us a center of mass 220 million light years away, near another supercluster. But then in the mid-2000s, we discovered something that was even more massive behind that. And when I say massive, I'm talking about mass. This object, called the Shapley supercluster, is 650 million light years away and has an estimated mass of 10,000 Milky Way galaxies. Compared to the Virgo supercluster that we're a part of, this is like the difference between Duluth and Manhattan. This is cornfields versus skyscrapers. It's the most massive thing in the entire observable universe. It uses black holes to pick its teeth. So what's giving us our peculiar velocity? Is it the Great Attractor? Is it Shapley? Is it something even bigger, even farther away? We don't know. We can't see into the zone of avoidance clearly enough to figure out what's out there. All we're sure of is that we are being drawn by gravity toward an area of hypermassive space. So, sleep tight, everyone. Thanks for